Thank you all of you. Very good morning, myself Professor Pallavi. So now this is the second day of the international conference. We'll be starting with the first keynote speaker of the day, Dr. C. Chandrasekhar Yadav, who is the professor and dean at NIT Greater Noida. He has more than 25 years of employment in academics. So his area of research is cloud computing and computer vision. He has published various research papers in reputed journals and conferences. Welcome to you, sir. Huge round of applause, please.
All of you. Thank you, ma'am, for nice introduction. But I want to add one thing in my introduction. I have recently completed my postdoc research fellowship from IFC Brazil. So first, I would like to thank convener and co-convener of this conference for inviting me here to address you all on the International Conference on Recent Trends and Intelligent Computing and Communication. Very nice topic. Intelligent computing and communication. Now the era of intelligent computing. And I couldn't attend Mahakumbh of Prayagraj, but I am blessed here to attend Kumbh of academicians, researchers and innovators. And here we will definitely get Amrit in this Amrit Kal of India. So first I would like to explain what is the meaning of intelligent computing, how intelligent computing differs from traditional computing. Actually, traditional computing is based on rules. We define the rules and regulations, and according to that, we compute the things. But in intelligent computing, actually, we make decisions from the data. We infer patterns from the data. So in intelligent computing, there are many things like machine learning, AI, deep learning, and if we compute with the help of these things, then that is called the intelligent computing. Same way as the human being compute the things, same way as human being think, talk, walk and see the things, and we try to simulate that things in intelligent computing. Second thing is intelligent communications. Obvious, we all know that what is the intelligent communications? Exchange of information from one place to another places with security, and that communication should be in multimodal mode. Means we can transfer text from one place to another place, we can transfer video from one place to another place, and then we transfer the emotions from one place to another place in the form of that emotion is embedded into the faces, text, and you can infer that things from the text and video. Whether that person is happy or not, you can fetch that things from the face, image of that person. So this is called intelligent communications. So very nice topic, and I would like to thank organizing committee for this conference, like recent trends in intelligent computing and communications. Now today, in this keynote speech, I want to cover these things: introduction to intelligent computing and communication, emerging trends in intelligent computing, advances in communication technology, intelligent systems in real-world applications, challenges and ethical consideration, and my research work in postdoc fellowship, and then conclusion. So please see this slide, intelligent computing refers to advanced computational techniques that leverage artificial intelligence, machine learning, deep learning, data analytics to solve complex problems autonomously. It involves systems that can perceive, learn, and make decisions in real time. I want to tell some history about this intelligent computing. In 1958, Frank Rosenfeld invented perceptron, and he was very much excited. And he said, now this perceptron will be able to learn, walk, think, and reproduce the another perceptron. Very much excited. And journey started from perceptron. But I think in 1961, Marvin Minsky criticized that model and said this perceptron is not able to solve the XOR problem. Only perceptron can solve linearly separable problems. Then I think the research slows down in the field of neural network. Then again, I think in 1972 comes the concept of multi-layer perceptrons with back propagation. And then with the help of the multi-layer perceptrons, we can develop non-linearity relationship between input and output. And all the problems will be solved by MLP. But at that time, computational power is not that up to the mark, and so research is not so fast. But after the invention of fast high computing power, then comes the concept of CNN, convolution neural network. And as you all know that father of CNN is, or you can say that there are contribution of many scientists. First is Jeffrey Hinton. Contribution of Jeffrey Hinton is in the MLP with back propagation. Then second researcher is Jan LeCun. And Jan LeCun invented his own CNN model LeNet 50. And then people realized that CNN, we can apply CNN in any field. And now we can say that AI is everywhere. There comes a revolution in the field of AI after the CNN. And as you all know that all three researchers, Jeffrey Hinton, Jan LeCun, and third one is I think Bingen, was awarded with Turing Award. And Turing Award is one of the most prestigious awards in the field of computer science. And then comes various models like CNN, then comes RNN, LSTM, and nowadays transformer comes. And as you all know that history behind the transformer, one paper published in 2014, I think 2014, that title of that paper is Attention is All We Need. And now through transformer, training is very fast. Why? Because in LSTM and RNN, we train the model sequentially. But with the help of the transformer, we can train the model parallelly. And then we can perform various tasks with the help of the transformer. And transformer with GAN, generative adversarial network. And as you all know that with the help of the GAN, we can generate the images, we can generate the music, and feel that is the real images or real stories. So there are various advancements in the field of AI. Now the era of transformer. You see the Gen AI tools like BERT, ChatGPT, then DeepSeek. Behind these tools, there is a transformer. So now you should use that transformer in your project work. So that's all about the intelligent computing and history about the deep learning, how this deep learning evolved. Now the data set is in terabyte, petabyte, and we train the model with terabyte and petabyte. And we should all proud of that. Father of deep learning is academicians. Geoffrey Fenton is a professor in University of Toronto, and now he is in the research lab of Facebook. And second one is, I think, University of New York, Lee Yoken, and that is in the Google Deep Brain. He is working. So in foreign, I think all the professor is associated with industry, and whatever professor write the paper, then industry is using that concept, and then commercial purposes. You see, Facebook is using all the tools. Suppose you upload all the photographs in Facebook, and recently they sort that photo in chronological order automatically. Behind that, there is a transformer. Through transformer, that arranges the photographs. So all the data is they kept in their data centers, and then using the tools, they commercialize the things. They are tracking the customers. There are various fields. Every field you can use deep learning and transformer. Now the era of artificial intelligence. Every software comes with AI. Oracle 7, then Oracle 8i, now Oracle 23 AI. Why? Because through natural language processing, we can generate the code. Through prompt engineering, we can create the code. There is no need to third generation languages. There is no need to remember the syntax. You can generate the code with the help of ChatGPT. And this is called the Gen AI. So now the era is of Gen AI. Second thing is intelligent communication. Intelligent communication focuses on smart and adaptive communication networks that use AI to optimize data transmission, resource allocation, and decision making. It enhances connectivity, speed, and reduce the latency, security across devices and systems. And key technologies driving intelligent system is IoT, blockchain, and quantum computing. If we introduce quantum computing in our AI, then that will be give very fast result, and training will be very fast. So now the information we will store in the forms of qubits, not only the bits, not in the form of 0, 1, 0, 1, and various combinations of 0 and 1. So quantum computing, every country is now looking for quantum supremacy. Then emerging trends in intelligent computing. As I have already told you, AI, machine learning and deep learning, quantum computing, edge computing. Through edge computing, you can reduce the latency time. Blockchain for security purpose, neuromorphic computing. Now the era of neuromorphic computing. What is neuromorphic computing? The brain, we simulate how brain compute the things in the chip. We design application specific integrated chip that consume low energy and compute fast. Why? Because there are millions of the perceptrons, there are millions of the parameters, and if you train the model, then consumption of energy is very high. So through neuromorphic computing, we can reduce the power. So this is also a challenge, how we reduce the things, because human being want to develop machine like human being. As you all know that human beings have various sensors like eyes, we capture the images, and through ear we listen the voice, and then here is AI model compute the things, and then we act accordingly. Same thing we want to implement in intelligent computing and intelligent communications. So neuromorphic computing mimic the human brain functions for the AI advancements. Then key technologies, sorry. Again, advances is communication technology, 5G, 6G, IoT and smart communication, software defined networking, cyber physical system. Now, this concept is due to 6G and 5G networking. Suppose you have a cyber system and then cyber system is interacted with the physical system, and whatever we do physically, that will be transferred to the cyber system. And example of self-driven car, there is no need of the human being. So whatever information we store physically, that is in the same thing is in the cloud, and then from cloud again machine to machine interactions, machine to human interactions, all these comes in the cyber physical system. Then this is by the research, postdoc research. My research topic is intelligent classifier for identifying and managing the cattle using deep learning. So I want to share this story. I sent a mail to Professor Alexandria, I am interested to work with you. Initially he said no. I have no project, and your area is soft computing, my area is computer vision. Then I sent my profile with, share my profile with Alexandria. Then he said, okay, write a project on animal husbandry. Then we will think about that. So I write a project on animal husbandry, and that project was approved by the Ministry of Agriculture, Brazil. Then he sent me a application form to apply for postdoc research. And I applied that for postdoc, and I enjoyed the research work. Why? Because every country needs the computational power. If you want to do the research in deep learning, then you need a very powerful computational power. And computational power is related to money. And I think in India, not funded project, everybody is not facilitated with that fund. So I want to suggest you to please collaborate with the professor which is in the foreign university. Like 2 and 3 MT is are contributing so much in the field of AI. University of Toronto and University of New York. So if you will associate with any professor of that university, then your research will very fast. And APC will also given by that professor, because they received a lot of money from the Ministry of Agriculture. So if you want to publish your paper in open journal, then that APC will be given by that professor. You have to only work the things, write the paper, and if you need any subscription, then they will share their credit card and you can subscribe that tool. So I want to suggest all the researchers to collaborate with the professor of foreign university. So my one paper is published in agri engineering, and second paper is communicated in IEEE access, and third one is also communicated. So I think 3 papers we will publish in Q1 and Q2 journal during the 1 year. So I took admission in 2023 1st November and completed my postdoc 15 December 2024. So this is our project, huge need for sustainable precision animal husbandry. Computer vision is one of the best technologies for identifying and managing cattle in the livestock farming. Through computer vision, you can find out that whether your animal is in pain or not. Why? Because animal has no language. They can't communicate with human being. But through computer vision, you can track and monitor the health of the animals. And it is very helpful for the farmer to measure the health and comfort index of the animal in livestock farming. Our intelligent classifier help. You can count the cattle, census of the cattle, Through computer vision, you can count the number of the cattle in your country, then identify individual cattle and detect their activity 24 by 7. Suppose you monitor the things ki consumption of fodder on this date is this amount and another date is very less. It indicates that your animal is not in good health. In this way, we can infer the things and we can monitor our animal intelligently. It classifies bovine with an accuracy of 95.8%. It is better than the model based on the Keras framework with pre-trained model VGG16. This project would give our livestock farmers the best performance within their computational budget. Computational budget is very important. Suppose you develop a model and you are spending huge amount of the money, then there is no use of that model. These are the various challenges and you should consider in your research work. Again, these are the various computer vision tasks you have already know. Image classification, object detection, image segmentation, facial recognition, image captioning and action recognition, then self-driving car, medical imaging, security and surveillance, manufacturing, retail. Now there are various dimensions of the deep learning. If you are doing project in the field of deep learning, you should consider these factors. First is data dependency. As you all know that deep learning is data hungry and huge amount of the data. Second one is hardware dependency. You need GPU, TPU and application specific chips, neuroformic computing chips. Feature selection, training time. You have to reduce the training time with the help of high computing processors. Feature selection is automatic in deep learning. You should not worry about the feature selection. In machine learning, you have to select the features and on the basis of that feature, you can predict the things and then you can classify the things. But in deep learning, CNN is very powerful and that CNN extracts the things. And there are various pre-trained models and you can use that pre-trained model for your research work like VGG16, ResNet 50, ResNet 152, then again mobile net, then exception net, efficient net. A lot of pre-trained models are available and you can use the weights of that pre-trained model and then you have to only tune your proposed model for classifying the things and for predicting the things. And there are various platforms like RoboFlow and YOLO 8, YOLO 9 is very good for object detections. So feature selection, but nowadays what is happening in the black box, that is important. Actually you can get the result, very good result, 99% and validation also, validation result is also 99%. But what is happening in the layers, hidden layers, that is important and you have to explain that things. CNN in ResNet 152, there are 152 hidden layers. And suppose what is happening in that hidden layers, you have to explain the things. So you have to disable all the hidden layers and only enable one hidden layer and what is happening with your input in that layer, then you can justify the things, what this model giving 99% result and this model is giving only 72% result. And if you write that things in your paper, definitely that paper will be published in high impact journal. Interpretability, that is called interpretability. Second is prediction time is fast in deep learning. Training time is slow, but prediction time is very fast because you capture the weights and after applying the weights within this fraction of the second you can get the result. So already prediction time is very fast in deep learning, but you have to reduce the training time. This is the challenge. Representation learning. Representation learning, already there are two layers generally in deep learning. One is convolution layer and another one is pooling layer. So through convolution layer, we use the filter, and with the help of the that filter we scan all the images and we can extract the features. So in the starting layer, you extract the just like edges, then look features you can extract in initial layers, but at the higher layer you can extract the high level features. And this is the reason we use the CNN in everywhere. Why? Because there is no headache of feature extraction. And max pooling reduce the size of the images so that we can save the time in computation. Without loss of important information, we can reduce the size of the images. Suppose the size of one image is 200 cross 200 into 3, and you are trained 19,000 images. So imagine how much matrix multiplication is going on. So max pooling layer reduce the size of the images, and we can reduce the computational time with the help of that max pooling layer. So repeatedly we use convolution layer, max pooling layer, convolution layer, max pooling layer, then various technique for resolve the overfitting problem, batch normalization, dropout. These are the various mechanisms through that we can reduce the overfitting. Yeah, we can remove the problem of overfitting. And generally we use ReLU activation function in our deep learning. Why we use ReLU? To establish non-linearity, and one major problem happens with the help of tan-H and sigmoid activation function. What was that problem? Gradient vanishing problem. So to avoid that gradient vanishing problem, we will use ReLU functions. Then I want to share some data sets. So the data set is very important. So there are various sites through which you can gather the data. Microsoft Coco. Through YouTube, there are various video clips. There are various tools through which you can convert video into the images. Because video is also images, and we run that images, all the frames in very less time. So you realize that the picture is moving, but actually that is the collection of still images. So there are various tools, and with the help of the video clips you can generate the data. And then text squared. If you want to train your model with the help of the with text, then Wikipedia and text squared, Google text squared, you can download the data set. Google audio sets. If you are developing the speech recognition system, then through Google audio set you can download the data. And I think you all are familiar with Kaggle. Generally all the researchers are using Kaggle sites for downloading the data. So only Kaggle site is not available. There are various sites from where you can download the data set, and then important thing is you can also generate your own data sets. Now everybody has a smartphone, and try to generate your own data sets, because if in your paper you will describe the public data sets, then nobody will care about that. Oh no, this is the public data set. And if you will write in the paper, I have generated our data sets and then obtain these results, I think that paper will be published in high impact journal. So in India, data generation is very slow. We generate the data, but upload to the Facebook, and Facebook using that data sets. Each and every activity you are uploading on Facebook, but Facebook utilize that data set to develop AI tools. Pre-trained model, ResNet is very good for image classification. But pre-trained model is very much useful for text classification. If you want to segment your image, then you can use UNet pre-trained model. For image translation, you can use pix-to-pix model. For object detection, you can use YOLO. speech generation, you can use WebNet. If you will use this pre-trained model, then training will be fast. Hardware, you can use TPU, NPU, application specific integrated chip, and this is the FPGA, field programmable gate array. You can also use these hardware for training the model. Now, actually our supervisor first give me the image of goat and sheep and say, classify these things. Because if you want to classify dog and cat, then easily classify. But similar type of the images, suppose we give the image of twin and say classify. One is Ajay and other is Vijay and classify this thing. So very difficult. So that challenges images he has given to me and I develop a CNN classifier. But these are the snapshot of the goat and sheep. So first we develop a CNN model with two convolution layers and each followed with pooling layers to learn the things, how to develop the classifier. So this is the result, and as you all said that the result was very poor because no syncing with that. Then CNN model with two convolution layers, each followed with pooling layer, and performance of CNN model is this. Recall value is 56% for sheep and recall value for the goat is 100%, but the precision value for goat is 68%, not encouraging result. Then I use pre-trained model, inception pre-trained model, and with the help of also result was not encouraging. Then I use pre-trained model, mobile net, and see again result was not encouraging. Then I explore another model, VGG16. Here better result. Why? Because in VGG16 are trained on 10 million images, ImageNet. So I used the weights of that pre-trained model and applied that weights into our proposed model, and we get this result: 76, 94, 84, 93, 72 and 82. Then I use ResNet. That's why I am saying that ResNet 50 is very good for image classification. Again I apply ResNet 101, then I apply ResNet 151. So these are the result of various pre-trained models. And in last I use YOLO 8 model on RoboPro framework and result is 95.8%. So in the last conclusion, future research may extend this classification to include other livestock like cow, buffalo, pig, species such as cows, pigs, improving its versatility. You can find out the various breed of the animals. Integrating the model with IoT devices and edge computing can enable real-time remote monitoring. You can deploy this model on drone, and with the help of the drone, you can find out the number of the cattle in a particular section. In addition, refining the model to adapt varying environmental conditions and incorporating multimodal data such as images, voices and captioning. Nowadays is multimodal. Actually, suppose you have a face of animals. Through face, we can identify whether the animal is in pain or not, but you can also record the voices. So if animal will be in pain, then different type of the voices comes from the animal. So with the help of the both type of the data, if you predict the things whether the animal is in pain or not, that will be good. So now the era of multimodal. Okay. Thank you, and I hope you all will enjoy this session. Thank you very much.
intelligent computing and deep learning. Now to facilitate, I request HOD ma'am, Dr. Pushpa Chaudhary and Dr. V to present the token of honor to CS Yadav sir. Thank you so much. Next, we have our speaker, Dr. Amreen Ahmad, who is an assistant professor in the Department of CSC at King Khalid University. Her research interests are data mining, social network analysis, and machine learning. Her skills are online social networks and social network analysis. She has a lot of research papers. She'll be there with us in an online mode.
Okay, good morning everybody. Myself Dr. Amreen Ahmed. Currently I'm working as assistant professor in the Department of Computer Science, King Khalid University, Saudi Arabia. Previously I had taught in Galgotias College of Engineering and Technology, and it was a great time teaching there and working with all other faculties. So today I'm going to give a presentation on trust network based recommender system. Okay. Is the slide visible? Yeah. So today I'll be giving presentation on trust network-based recommender system. So the topics that I'll be covering is introduction, literature survey, research gap, problem statement, solution, experimental analysis, conclusion, feature scope, and references. So to start with, first we'll see what's a recommender system. A recommender system is a subclass of information filtering system that seeks to predict the rating of reference that a user would give to an item. Examples of recommender systems are content recommenders for social media platforms such as Facebook and Twitter, playlist generators for audio and music services, etc. Now, there are different types of recommender system. They are collaborative recommender system, content-based recommender system, hybrid recommender system. Now, what is collaborative filtering recommender system? Collaborative filtering techniques use either the similarity between items or between users to predict a user's preference for new items. Advantages are the system doesn't need content. Serendipity. Every recommender system tries to achieve the goal of serendipity. It involves gaining user confidence. New and applicable solutions are made available to the user that differ markedly from the items already rated by the user. Now, there are some disadvantages of this collaborative filtering recommender system. Sparsity. It means if we don't have enough users in the network, then we cannot find out the similarity between similar users. Then next one is score start. If a new item enters the network, then it doesn't have any ratings given by the previous users. Scalability. If the number of users increases in the system, it becomes hard to make recommendations since the computational complexity increases. Next, contents-based recommender system. Recommendation systems based on the contents-based approach calculate the similarity between items based on their textual context. The advantages are user independence. Collaborative filtering needs other users rating to find the similarity between the users and then give suggestion. Instead, content-based method only has to analyze the items and user profile for recommendation. Transparency. Collaborative method gives the recommendation because some unknown users have the same taste like you. But content-based method removes the items based on the features. No gold star. Opposite to collaborative filtering, new items can be suggested before being rated by a substantial number of users. Now, there are some disadvantages of this technique. It is new user. When there is not enough information to build a selected profile for a user, the recommendation cannot be provided correctly. Third recommendation system is hybrid recommender system. It is a combination of both collaborative filtering and content-based recommender system. The advantages are it not outcomes the disadvantages of both collaborative filtering and content-based recovery system. There is multi systems, computationally complexity is very high. Now we will see one problem statement that was basically my research area that had solved. Uh, it's had basically created a trust network-based recovery system. The problem statement was the immense growth of information has led to the wide usage of recommender systems for retrieving relevant information. One of the widely used methods for recommendation is collaborative filtering. However, such methods suffer from two problems, scalability and sparsity. In the proposed research, the two issues of collaborative filtering are discussed and a cluster-based recommender system is proposed. The data set is collected from the students studying at Jamia Millia Islamia. The students were asked to rate the Bollywood movies three on the rating of four categories: thrilling, scary, boring, and entertaining. The ratings were on a scale of 0 to 5, where 0 denoted strongly agree and 5 denoted agree. Then to compute user scenario, all the students were asked to write 5 scenario. Now this is the proposed framework. The input data set was initially converted into a graph, then nodes were stored using Shapley value, then important nodes were determined from the underlying network, then potential community was determined using clustering algorithm, and then application of recommendation algorithm in every detected community. Preliminaries are Shapley value. Shapley value is basically a concept of game theory. The idea is we define a cooperative game over network in which players are nodes and coalitions are group of nodes. Shapley value is a solution concept that provides a unique expected way of allocation. Shapley value again prefix solution concept quantifies a role and importance of a game by computing average margin of competition of every player in the game. Now, the Shapley value for cooperative game represents the average weighted marginal contribution made by each player during the game. Mathematically, the formula for a Shapley value is given. Now, what's the research methodology? In the underlying graph, the salient nodes are determined by using spin algorithm for every node. Salient nodes are basically the important nodes on the network that have maximum coverage in the network. The salient nodes identified are used to determine the clusters in the underlying graph discussed in algorithm 1. Finally, the recommendation procedure is discussed in algorithm 2. So this is the proposed clustering algorithm. First will be determining the salient nodes. Then based on salient nodes are basically the smallest subset of nodes in the network that have 100% coverage. Then for each salient node, we determine the closest non-salient node using Dijkstra's algorithm, and then we form the community based on it. Now the recommendation algorithm is every salient node represents is a, for example, if we have 7 different salient nodes, so there will be 7 different the similar nodes to the salient nodes, they come into the same clusters. This is the procedure for recommendation system. Let me explain it using example. We proceed with the explanation of the recommendation algorithm described by algorithm by taking an example. Initially, the data set is transformed into a graph form. For this, we compute the cosine similarity of each user to each other user based on the descriptions provided. For example, we have 10 users. Here is Bob, Chandler, Derek, Ethan, Fatma, Gavin, Harry, Shita, Josh. And they have subscriptive sentences. So, table 2 shows the ratings given each user for different attributes: caring, boring, training, and entertaining of the movie 3. The descriptive sentences are created by removing punctuation and stop words and stemming the result tables. The result of text screening is given in table 3. These are the ratings given by 10 users based on 4 attributes. And after text screening, the whatever we get is presented in table 3. Then table 4 we have and cross matrix, that is the number of users. We have 10 users, so it is a 10 cross 10 matrix, and we are computing the user to user similarity based on descriptive sentences. Then, based on that sentences, we have in table 5 actual and predicted ratings given. Now, this is the clustering. We have 5 users, 2 clusters are formed, and we divide the clusters into training and test sets. Now, the evaluation metrics that we have used is means absolute error and mean square error. The formula for the mean absolute error and mean square error is given in the slides. The experimental access is depicted in table 6. As we can see that we have compared the proposed system with collaborative and hybrid algorithm. Similar to conventional algorithms. The reason for the good performance of the proposed approach is the incorporation of information distribution concept of Shapley value to identify potential communities by the alignment. So the conclusion is the proposed research tries to overcome the drawbacks of traditional collaborative computer systems, capacity and skill limitations. The proposed system is divided into two modules, community detection algorithm and remuneration algorithm. A Shapley value-based non-overlapping community detection algorithm is proposed to detection community that divides the large set of users into different clusters. The future work remains to develop the overlapping community detection algorithm. This is all, and these are the following references. So if you have any query, you can ask. Samir sir, this is all what. If there is any query, it can be put up. Samir sir?
Thank you so much, Dr. Amin Ahmed, for being here.
Yeah.
So I propose,
Okay, now.
yeah. Any queries from the audience side? So at least I can start with the query session. Ma'am, better if you can share this PPT to us, so at least people can view this and they'll ask you later on.
Yeah, sure, ma'am. I will send the slides to the semester. Okay.
Thank
So
you
it
so
was
much.
nice interacting with you people.
Thank you so much. Take care.
Okay, thank you.
Galgotias University of Lee and Plus University. She earned her doctoral and master's degree from Indian Institute of Technology, Indian School of Mines, IIT, ISM, Dhanbad, Jharkhand, and bachelor's degree in computer science and engineering from Rajiv Gandhi Technical University, Bhopal. She is having 3 years of experience in the field of academic and research in various disciplines like machine learning, artificial intelligence, algorithms, image processing, geographical information system, and database management system. She is actively contributing as reviewers of welcome, IEEE conferences, and she is also working as a SCI reviewer also. Welcome, Dr. Rupaki.
Thank you, ma'am, for introducing me. So, is my screen visible on you?
Yes, you can start, and we are able to see your PPT.
Thank you, ma'am. So, good morning to all of you. And I'm really glad you all, my colleagues and friends. And I'm really grateful for the
Can you be a little bit larger, ma'am?
So I'm fully grateful to speak at this conference, and I would like to extend my heartfelt thanks to the organizing committee and the entire Newly family for making this event possible. So without taking much time, let's dive straight into our discussion on digital twin. So digital twin is an emerging technology, and it's still leading the multiple ways while which we can reshape our future, and it has many capabilities. So today I will be discussing on digital twin. It's the basic concept, technology, processing, and applications that we will use, and this space and the architecture. So these are the outline of my presentation. So first, like digital twin. So what is digital twin? Digital twin is a virtual replica. So in this application, the system is bi-directional communication link. So it can be split into two parts. One is
carry actuators or human physical members. But in both the cases, digital twin should be capable to capture the details about the physical entity and its changes. So we can say it's just not the virtual representation of the physical entity, rather it's the evolving representation which continuously interact with the physical environment. Now, in processing this stage, it has many steps. Like first, action take place in the physical environment. Then some data collection devices is operated, and then they measure the reality, capture the reality, and after interpreting the data, they update the user model. And after using various data analytics and simulation algorithms, they produce some decision, and then that decision is reflected back to the physical environment by
आराम से निकालना
using
है,
some
तुरंत नहीं है।
actuators. Now, digital twin integration level. So basically, regarding this technology in the digital twin, it's just showing the relationship between the physical thing and the digital model. So here, in the case of digital model, the data flow from physical to the digital one, and from digital thing to the digital one, both are manual. So we can say there is no automation. If we update this flow of data from physical to the digital one, from manual to automatic for this physical to digital one, then it becomes a digital shadow. So we can say in the case of digital shadow, there is no automation in the digital representation. Whereas in the case of digital twin, it is fully automated. The flow from the way is placed on automated. So in summary, we can say digital model is a static representation of the reality with no automation. Digital shadow, digital representation has partial simulation, partial automation, and in digital so now in digital twin can be different depending upon the context. Like in the manufacturing industry, it starts with the digital twin, and then digital twin rapidly into the product. Whereas in the case of construction, first they visit the work site and then they try to adapt the building design. So we can say in both the cases, they start with the digital twin and end up with the physical twin in a linear time. Whereas in the case of maintenance and other planning, they are cyclic in process. So here both the twin are changes because so if in the maintenance, we can say if a building is under maintenance, then we can say it's a part of which is acts as the area of interest for a particular population. So in urban planning, we can say different area could be a part of interest which is operated with different intensity and frequency. Now, like to enhance the operational efficiency, digital twin use different type of technology. Some of them I mentioned here, like surveying and mapping technology. It is important one because it is the only responsible for connecting the reality and it's creating the 3D representation of the physical environment. And it includes sensors, many surveying techniques, radar, GPS, and drone mapping, lot of things. Like next one is building information modeling. It is a detailed 3D representation of a building. It gives complete detail about the building, either related to its like component or its operation, helping decision making for the decision makers or stakeholders. Next, 5G enabled IoT. It connected millions of smart devices responsible for reliable, fast, real-time communication. Then simulation technology, we can say like simulation technology is a cornerstone technology for this digital twin. It allows us to test and predict various market scenarios. Now, edge computing facilitates this by increasing the processing time of data, and it increases its responsiveness and allow for the real-time processing. Now, cloud computing, helps the digital twin by storing or
managing the large amount of data. Whereas extracurricularity is a combination of AR, MR, and VR, and it enhances the visualization. It enhances the visualization and interaction, so which increase the stakeholder participation, so helping decision making. Whereas AI helps digitally by enhancing its data analysis, prediction, and analyzing capability, and making real-time decision making possible. Now, based on the combination of technology, digital twin have many applications, and like agriculture, automobile, and aerospace, healthcare, city, etc. So, like electricity, so digital twin can be implemented to monitor and optimize the performance of a power plant and grid, and it's making it scalable and reliable. Like in agriculture, digital tools help farmers by creating the virtual replica of this farm and crop. So it helps in smart agriculture, optimizing agricultural processes, and monitor crop health, livestock metrics, etc. So in automobile also, they are using digital twin for car designing and testing and virtually, so they can understand the performance of car and predict its maintenance. Similarly, in aerospace also, they use digital tools to simulate the aircraft performance. In healthcare, we can use digital tools to diagnose the disease and like preventive treatment and monitor the healthcare devices health, education and training in various fields. In city also we have various domains like transportation optimization, parking management, waste management, water management, smart home, smart education, construction, emerging awareness, safety, so likewise based on the like characteristic we can use this doing in multiple domains. So now let's take a closer look at one specific application of digital twin in a city. So in the case of city also, digital twin is a virtual replica of the city with a bidirectional. So here this link includes operate all the data about its landscape, buildings, data flow, mobility flow, etc. Whereas decision make some data process that next take place here, and after making some analysis, it transfer the decision to the reality. But here I put a question mark because the implementation of digital twin is ongoing globally, but still the full automation remains untouched. So it raises a question whether we will able to achieve full automation in the case of city, or there will always be a human in the loop. So now with the input to understanding of digital twin in general, we can now understand better the intention of urban digital twin. So basically, urban digital twin allows for real-time monitoring, analysis, and simulation, and it provides valuable insight for the urban planner to improve urban management and sustainability. So here we use urban digital twin as a decision support system. So there are a lot of domains in which we can take help of digital twin in making decisions. Like scope, here we have like in the design, if we want to change physical environment, something like if you want to create new infrastructure, then it will give us like predictive analysis. Or in operation also, we classify the two things, human decision maker or automated decision maker. So if we want to make that like system, then of course in this case the algorithm can decide. And if we want to change some road pattern, something like that, then in this case human decision making is required. Intervention simulation in the opposite side of something. So there are a lot of we have different domain for decision, like mobility, power supply, water management, civic management, etc. And we have different type of user in the case of city to make a decision, like for policy makers, citizen, urban policy makers, decision maker, and public servant. Now, the urban digital twin, in a case of city, urban digital twin built on like various layers of information. Here I describe the six-layer architecture for this urban digital twin. So here the first 5 years are responsible for the data collection. The last one is responsible for the income analysis, right? And the views here, first we collect the data from the topography, land cover map. Then the first layer gives detail about the buildings, and the next one is gives detail about its infrastructure, and then third one is mobility. So for mobility, we divide it into like transportation, motorized transportation, and non-motorized pedestrian and cyclists. So by using the simulation algorithm or Unity, we can collect the responses this data. And after collecting all the data from the fourth layer, we produce in the digital layer, and then the virtual layer by which machine learning and AI and decisions transfer back to the physical reality. So this is the main component architecture of the digital tool, how we will implement this. So here we have two main component of the digital. First one is data sources and volume. So here data sources include all the sources of data. So in the case of city, we have different types of data sources like the demographic, IoT data, GIS data, urban data, sort of type. So here we divide the data into types, dynamic and static. Dynamic is the data which is changed frequently. So here we consider IoT data, and the static one is your data. And the next one is model. Model is the algorithm. So here we all type of the algorithm to make the analysis. And if they are which is just like give us how the different components connect with the system. Then broker. Broker is like a software component which is responsible for publishing the data. So here all the data resources publish their data, and based on the requirement, users can subscribe their particular data. The broker is a component which is responsible for the data transfer, how different components within a system connect with each other. So it is the one which is not storing the data, just transferring with others. So for this data capture, like detailed inventory of the data is just published the available data inside the model, and knowledge graph will just give the detailed graphical representation about the data. So for the data integration, because the data is available in different formats, we need some integration language. So here we use the knowledge graph technique. And context graph is the to visualize the after fact of the physical. So what is the current state of physical reality, and after making some figure what will happen. So now if you want to design a basic unity, then it's a basic step. Then first you have to collect the data, then integrate the data, and then make some 3D models by using some software or techniques, and then connect with the real world, and then by using some simulation and machine learning things, you can predict a predictive model in them. So here, during deployment stage of Unity, we faced multiple challenges. So we divided these challenges into two things: technical and non-technical. In technical, it's like data quality. First one, because poor data leads to the ineffective decision making and fraud insight. So data quality is important. And next one is data integration and management. Because we have different data in different formats, integration is process. So they have different type of challenges. So I guess we are running out of time, so I keep it short. So if anybody finds interest in this, please feel free to contact me. I will
Thank you so much, Rupali ma'am. We are very happy to see you after a long time. Thank you so much, ma'am. Hello, Rupali ma'am. Am I audible?
Yes, yes, sir.
Thank you so much, Rupali ma'am, for the lovely session. Thank you so much. Am I audible to you? So, welcome, sir, to the second day of the international conference. Uh, he's a professor at NIT Patna. His area of expertise is wireless sensor networks, IoT, cybersecurity, data science, and software engineering. As we all are from computer science background, definitely we are going to take benefits from your session, sir. Thank you so much, sir. Over to you. You can start, sir, with your PPT.
Okay, good morning everyone. First of all, I want to congratulate the organizers and Galgotias for organizing this conference. I'm putting my screen.
You can put it on full screens. Yes, sir. Perfectly
Yeah.
fine, sir. Welcome, sir.
It is visible?
Yes, sir, very much.
Okay, okay. So today this discussion is about social internet of things, and in the time available, we will be discussing right from smart objects to the social objects and the future of IoT. So as we all know how things are changing and the network of the entire world is changing. So keeping in view the scenario today, you can see the global internet map. This is of around 2021. How the different components are connected through fibers and links. So we are finally moving to an era where everything is connected. So the future networking consists of large number of objects. They will use the standard communication protocol for the interconnection. We need unique and single keys, and all these things have many wide applications in many productive sectors, including healthcare, environment, smart home, workplace, security, surveillance. So the IoT is here to stay, and the requirement and demands are going to increase. And what are the key enablers of IoT? We all know that smart objects are the first thing. All the objects we use today are going to be smart, and there will be services built for them. So we need this to discover new services, exchange information, connect to external services, exploit other objects' capabilities, collaborate towards a common goal. The big question here is how simple objects will be evolved into smart objects. That has already been done. Now, any further evolution is possible. So, what is the future of IoT? And that's where we are talking about the social IoT. So, the future IoT means today we have connected humans on social networks. We all are connected to Facebook, LinkedIn, and so many other things. But now the next stage is connecting things. Now, if we are going to connect things, then how it is going to make our life easy and how the different kinds of research will be required. So today we are talking about connecting things in where our things will also be socially connected. So that is called the social internet of things. Convergence of internet of things and the social network domain, enabling social dimensions of connected devices, establishing and exploiting the social relationships among things. Objects can inhibit the social behavior of their owners. Things can discover assets and services themselves via social relationships and act as a personal assistant. Like, let's say we are four friends. We are connected to each other. Tomorrow, our mobiles will be connected to each other, and many of the things for which we need to call our friend, where I am going for the dinner. So these things the mobile know because you are searching using the mobile and your location is known to the mobile, where you are going into, at many times you are using Google Maps to know where you want to go. You put in your calendar there. So these things for now, if you want to know about your friends, the next step where he is or where you need to call it. Now, social internet things, if we are friends, our mobile may also be friends, and they can connect with each other and provide you services, saving your time, saving your effort, and you can utilize your time for your other purposes. So, objects from smart to social, how and why. So let us see this scenario. Humans are equipped with resourceful IoT devices like mobile phones. But these resourceful devices are idle for majority of time. Processors are not being utilized to the full potential. We have gigahertz of power, we are carrying it with us. Today's mobiles are almost equivalent to computers a few years earlier. So, if we embed intelligence into the device, then we can successfully offload the human brains from performing time-consuming tasks, like we can and thus utilize time for performing other productive works. We can spend time with family and involve in recreational activities. So we need to use our devices and use it so that we get information from our social circle. Because when you get information from your social circle, those information are trusted information. So make the right information available to the user at the right place and right time should be the aim of our social internet of things. Making the right information available to the user at the right place and at the right time. So as you can see, these are our social networks and these are the objects. Now these objects can have relationship among themselves also. And that is where we need to come up with new architectures, new protocols, and new security things so that the devices can be connected to each other, communicate with each other, and we can offload our time-consuming tasks to the devices. So the normal design of IoT is like we have actors in communication medium or an intelligent system where everything is connected to internet. As you can see in the figure, the consumer today is both. The humans are both as a consumer and also as a producer. So it's not that the data is produced only by the sensors and devices. We are also the producer of data. So what kind of relationship we are talking in social IoT system? It can be a parental object relationship, that is among objects belonging to the same production batch, objects manufactured in the same period by the same manufacturer. So they can be grouped together in a parental object relationship. Co-location object relationship among used always in the same place, depending on the sensors in the same environment or in your same one home. Objects connected to one home can have a co-location object relationship. Similarly, co-work object relationship can exist among objects that collaborate to provide a common IoT application, like objects used in telemedicine. Here, in co-work object relationship, it's not required that the objects need to be at the same place. Similarly, we can have ownership object relationship among objects belonging to the same user. Our mobile, let's say my mobile phone can talk to my music player, my game console, my fridge. So that all can be grouped together based on ownership. Similarly, there can be social object relationship among objects belonging to social owners. Here, objects share the same relationship as that of the owner. So we are more talking about in this domain where social object relationship can exist between the friends or the family members of a particular human, and that's where you get information which are trusted. So like, let's see this application scenario. I need to purchase several items. Now, which is the best option for me? Maybe my friend, my family member, they have some experience. So that can be immediately automatically you know what is more spicy means for you, because more spicy for America is different from more spicy of an Indian. So these kind of trusted information at new place can be made available to you at the time you land at that airport. So this is where social IoT is going to change our life. We may often have gone with this kind of situation, like two of our friends are in the same mall, or even I go to a mall from my office, my family go to the same mall from their home, and we do not know because the plan is not pre-planned. So though we are at the same location in the same mall, maybe we are at different place and there is no chance of meeting. But if we enable the social dimension of our objects, our mobile phone will know that we both are connected to the same tower or we are in the proximity. So they can inform the user that, okay, there are chances of meeting because you are at both at the same place. So this is the scenario where things are going to change in very near future. What are the current challenges? Contacting individual person one by one is very time consuming. Most of the people in the social circle of the user may not have the desired information. Most of the online reviews are not centrally moderated. So the objective of providing users with recommendation about a product, place, etc. based on the opinion of the user's social circle is going to require a new architecture, a new way of handling this data, and we need networks and privacy settings, security settings, so that things can be handled. So there can be many ways where these things can be done. So today, due to time, we need to think also what is the major issue. Major issue will be management of huge volumes of data generated in the complex IoT network. And who is generating the data? It's not the sensor and actuators alone. We humans are also working as a sensors and generating data. Our movement, our buying pattern, our typing, our social media posts, these are also the data. So humans are also working as sensors. So what are the potential barriers of IoT? So network constraint, concerns about vendors' sustainability, unpredictable performance, data portability and ownership, open standards, not compatibility across devices and systems, legal, regulatory and compliance barriers, lack of internal technical expertise to implement and operate, difficulty integrating an operational technology, definitely the price and economic things, and last but not the least, the security concern, because the more open you are making it, you are allowing devices to communicate to each other without human intervention. So we need to have proper privacy and security policies in place. So thank you. I know I have limited time, so thank you.
Thank you so much, sir. Very informative session. I'm asking to the audience if there is any query, please.
Hello.
Good morning, sir. You're audible, sir?
Good morning.
My question is, I just want to know the relevance of social IoT.
Okay. It is very relevant. Some echo is there, but it is very relevant because we are carrying devices which are mostly sitting idle, and we humans are working more. So let us offload our day-to-day or time-consuming or monotonous job to the devices, and we get time for doing recreation or family time. That is the whole purpose. You see, you are carrying a mobile with gigahertz of processing, maybe 8 GB of RAM and all those things. But what is doing right now? It's just sitting in your pocket, doing nothing. And now, how you will go home, or which movie you want to watch, or what, from where you need to shopping, you will go and search it individually. Or you want to plan a holiday, you will go to some site, see the ticket prices and all. All these things can be offloaded to the device, which can do this in the background and inform us the results. So that is where the social IoT comes in. And for doing that, it can also connect to those of our family circles who has got experience in those kind of things. Let's say you want to go to a new country, you want to know something. So you can phone to each of your friends and know who has gone. The other way is his mobile know that he has gone to that country. If there is an architecture, the mobile will you that you need to connect to this email. So that is where the social dimension, it gives you a trusted information at the right time and at the right place. So that is the main purpose.
Thank you so much, sir,
Hello?
for the wonderful session. We are so glad that you had, taken out time for for giving us this invaluable information. Thank you, sir.
Thank you.
Thank you, sir.
So I'm disconnecting.
Okay, sir. Thank you. Thanks again.
Thank you.
A very good morning, sir. Uh, so we welcome you. So now we have our next keynote speaker, Mr. Shivraj, who is the Senior Manager of Threat Detections, Amazon Austin, Texas, United States. We are very glad that you have taken out time for us. So let's have your session. Over to you, sir.
Okay, it's for me. Cannot see you guys. I mean, is that something the video is not on at your end?
So we are able to see you, no problem, but here is a network glitch, so we are unable to switch on our camera. So that is why, sir.
Sounds good. Not a problem. It's almost a midnight here, so I might, if at all I'm blabbling on something, I mean, you guys have to just point me at it. But thank you for this invite. Firstly, for me to come over and talk. And the topic which I want to talk is mostly around the threat detections itself. I mean, given I have been thinking about what do I put forward for you all, specifically in you guys have good theoretical knowledge and you also do so much of experience. So I thought I would probably bring in some of my industry experience here to tell you what we do here at Amazon and what kind of work specifically I do on the threat detections that's the domain that I operate in. So I wanted to mostly talk about that. I did prepare some slides. And this was something one of my friend he mentioned slide would be better, so I thought of having a slide. Is it something I can share? Is the share works here?
Yes, sir, you can share your presentation. I think we already have given you the permission.
Does the screen share work for this or?
Yes, sir. Yes. We are not able to see it right now. You can use that share presentation option at your end.
Okay. Alrighty, so let me quickly see this. Let me know if you can see this. I'm sharing my presentation now.
Yes, sir, your presentation is very much visible to us.
Alright, so I'll be very quick. I won't take much of the time. So I'm Shiva. I am leading the engineering division here at Amazon, and I take care of the threat detection coverage for Amazon. So that's my responsibility. And once again, so just what is threat detection? If you guys think about it, I mean there are so many external threat actors. Especially for the companies like Amazon, we do see much of the attacks coming in from Russia, China, and sometimes from South Asia as well. So all these attacks, they are either targeted to get the Amazon customer information, or sometimes they are also targeted to bring down Amazon as a service too. So my team's responsibility is to quickly detect the threats that we see at Amazon, and within probably like 6 to 10 seconds we know the incident, so that they go and they handle the threat, they stop the threat from happening. So to do that at Amazon scale, something that we do is Amazon generally it's massive, right? I mean, so doing it for a small instances and small company, it would be probably easier, but do it at a scale at Amazon fashion. Those are the challenges we face. And some of the challenges here is like we process around 20 petabytes of data every day, which means around 300 trillion events that we look into. And we have built this system, which is again patented, very proprietary for Amazon. My team built it, something that I'm proud of. And it detects threat within 10 seconds. And for any new threat that you see in the threat landscape of like something new comes up, we tend to build the detection coverage for it in 60 minutes. It's contextual, intelligent, and the auto containment also happens for this thread. How do we do this? Again, we are taking a workshop of Java, and many of the folks here are latest structures. They are very good at all of those, looking into the file window access and all. And we have also been using much of this latest technologies like GenAI. Containers is something that we heavily rely upon, the AWS containers, and we use CCS on EC2s. We built everything custom here, I mean, because at this scale, if we have to handle it, and also alert within a couple of seconds, we need all custom built DSLs. And we also have our own control plane, which is React Angular and all that stuff. It could go more if you guys are interested, but I want to quickly talk about GenAI. I think it's a very popular technology out in the market. Something that is replacing a entry-level engineer, or probably you could consider GenAI as a proxy engineer itself. So we have been extensively using this, especially for the scale like us. We need a reasoning engine. We need to feed that with the right data. We have been doing all of those. So there has been some good GPT models that we built internally that takes care of the detection of users and all. And with that said, closing notes. That's all I've got. It's already midnight, but I'm open for Q&A if you guys have any questions. So that's all. Anything from your end? Any questions at your end?
Yes, sir. Thank you for the insightful session. So I'm just going to ask to the audience, is there any questions? We are having lots of professors of this area only, so they are actually ready to ask you. Just a second, sir.
Okay, please shoot on.
So here is Dr. Sonal. She's going to ask you.
Thank you, ma'am.
Sounds good.
Hello, sir. Sir, I would like to know what are the tools for the containers that you have discussed in your presentation right now for the threat detection? What can be the tools we can use for that?
Tools-wise, I mean, we build custom built tools, and I think you guys might be aware of Splunk. If you are aware of that, I mean, it's basically you inject all of the telemetry into it, and then you can detect, you can write some logic, which we call it as detection to detect that. But for Amazon scale, we tend to always have the challenge of external tools not available or not scalable for Amazon volume. So we built internally. The container part that you asked, we use ECS on EC2. It's again AWS workshop too that we have here. So basically, we heavily rely on AWS because it's part of Amazon again. And ECS also has various different flavors. The version that we use is EC2 because it's very extensible and for the size that we process around 20 petabytes of data, it's easily extensible for that.
Perfect.
Hope I answered your question.
Yes, sir. So, sir, thank you for this. And sir, if possible, you can share your LinkedIn profile so at least the professors who are working on this area, so they can connect to you. Thank you so much.
Sounds good. All right then. Very nice seeing you all, and thank you.
Thank you so much.
It's my pleasure to thank all the keynote speakers, those who joined today for the keynote addresses. Today we have some of the renowned speakers like Dr. Chandrasekhar Yadav. We thank them for joining that particular session and to deliver a keynote session in our conference. Then next we were having a speaker, Dr. Prakash Kumar from NIT Patna. He joined us through the online mode. We also thank sir for joining that particular keynote addresses and to enlighten the students with their words of the wisdom. We are having some international speakers, Dr. Amreen Ahmed and Dr. Rupali Khare. We also thank Dr. Amreen and Dr. Rupali for joining the keynote addresses or to deliver a keynote address in our conference. And we wish to have them in the future, in the forthcoming conferences as well. The another speakers were Mr. Shivraj. He is also an international speaker. We thank Mr. Shivraj to joining as a keynote speaker. And lastly, the attendees, those who attend these particular sessions, because all the keynote addresses were meant for the attendees. So, from my side, I thank all the speakers and all the attendees for attending these meaningful sessions and by getting some of the current insightful trends, techniques, or some of the ideas to get some of the research work we may proceed with. Thank you. Thank you, ma'am.